This history is extremely special. It has been at this location for, we believe, about 125 years old. It was planted at the intersection of 4 backyards. These were railway homes back 120 years ago. It's lived a life. It's lived through wars, it's lived through storms, it's lived through climate change, and it's still standing in this parking lot. Calgary is a young city. We don't have as much history as some other places. And so it's important for us to remember where we've come from, whether that is our development and our settlement history, or whether that's the Indigenous history as well.
Digitally capturing heritage sites isn't new, but there's not been a lot of work focusing on what we call grassroots heritage sites. So these would be heritage sites that are of interest to specific communities or groups of people. So we're an interdisciplinary research group. So I'm an archaeologist, but I work very closely with geomatics engineers. And I also work with some folks in computer science. I became really intrigued with the idea of capturing this particular tree not only because it was an interesting object to document, but also because of what it really means to a variety of different people. There's a lot of memories associated with this tree. And we'd never scanned a biological heritage object. And from a kind of technical perspective, it presents lots of interesting challenges because there's no straight lines and right angles like you'd see in a human-made heritage object. Terrestrial laser scanning, which is what we do for most of our projects, basically it's like a 3D camera. So the instrument emits millions of points of laser light, and the instrument measures the amount of time taken for each of those points of laser light to leave the instrument, strike the surface of an object like a wall or a roof or a tree branch, and then return to the scanner. A scanner, like a camera, can only capture what it can see. So the trick is to move the scanner around and through the object to capture it from every conceivable angle. And then you stitch together all of those scans into a single three-dimensional object or image called a point cloud. And they exist virtually in our archive here. And you can see, for example, here's the Stampede elm. I can virtually manipulate it. I can look at it from different angles, but you can't touch it. And once that tree's gone, it's gone. So I was really interested in the idea of using 3D printing technology to create what's called a physicalization of the tree. We have both the virtual and the physical. In order to protect heritage, you have to understand why it's valuable.
One very, I think, interesting direction to use these models is educational for elementary schools, to actually let them play with it. If they were able to actually grab a branch and put them, assemble it, they can have a feeling of, oh, that was the tree.
In Alberta, we recognized that there's a lot of heritage that's currently at risk due to the impacts of climate change and human-caused destruction. So digital preservation, although it's never going to be as good as having the actual site, it's almost the next best thing, and it provides us with a way for future generations to appreciate our history as a nation, both good and bad.